Hello everyone, welcome back to our channel. In this video, we will discuss how to find gene interaction network using Stringdb. So let's get started. In this video, we will cover the following steps. Step 1 is to import necessary libraries. Step 2 is fetching gene interactions. In step 3, we will visualize the network, and at last we will run the code. In step 1, we will import the following libraries, including request library, Networkx library, and Matplotlib. Now, let's understand this code step by step. In step 1, we are importing necessary libraries. Here, we have used import keyword in all of these libraries beginning, because import keyword is basically used to bring in library or a module. Then we have request library. This library is basically used to send requests to the API. Here we are using Stringdb API. Then we have Networkx library. It is a library used for working with complex networks. And for this library, we are using NX as an alias. Then we are importing Matplotlib. It is basically used for plotting graphs. Then we have Matplotlib.cm. CM means color mapping. We are basically using this library to provide color map utilities, and its alias is CM. Then we have Matplotlib.colors. It is same as above. It is a module providing functions and classes for dealing with colors. This library is basically used to show the interaction network where nodes will have different colors and edges will have different colors. That's why we are using this library. Then we have step 2, where we are fetching gene interactions. We are defining a function named as fetch_interactions. It consists of 2 input parameters. First of all, we have genes. This is the list of the genes for which we want to find interactions. And then we have API key. By default, its value is equal to none. If no API key is provided, then API_key will be equal to none. Then we have base_URL. This variable is basically storing the API URL. For Stringdb, this is the API URL. So we are storing this URL in a variable base_URL. These are some of the parameters that we will provide along with this URL. This involves identifiers, species, and required score. Identifiers, this is basically a dictionary that contain keys. These are the keys, and these are the values. Here, identifiers is basically joining all of the gene names by separating them by a new line separator. Here we are using, this is a new line separator. Species is 9606, that represent human species ID. And required score is equal to 400. This means that basically in Stringdb, the interaction score ranges from 0 to 1000. 0 means no interactions and 1000 means stronger interactions. And here we are basically defining that we want to find only those gene interactions in our network whose score is equal to 400 or more than that. Those interactions that are less than 400 will be filtered out. Then we are using a conditional statement that if API_key is provided here, whenever we will call this function, then in parameters also within these parameters also add this API key into a variable equal to API_key. Now we are calling the library that we have imported here. We are basically using the get request. Get means that we want to get some information from that URL. Here we are providing the URL of the API along with some parameters that we have defined here. And then this function will basically return response. This is the response in the JSON format. Here we are basically converting this response into a JSON format. Here response.status code is equal to 200 means that if the request is successful or not. If the request is not successful, else return none. Now let's discuss step 3 for visualizing the network. We are defining a function visualize_network that will take data as an input parameter. This data is basically interaction data that we have retrieved here in fetch_interactions. Then we are defining a variable g that is using this library nx Networkx .graph. Here we are initializing an empty graph. Next is to add edges with weights based on interaction score. Here we are using the loop to iterate over each item in the data. Interaction is basically a variable, the current item in the iteration. Then we have protein 1. Protein 1 stores the first protein in the interaction. Protein 2 stores the second protein in the interaction. This score variable will store the interactions between these two, protein 1 and protein 2. G.add_edge will basically adds an edge between these two nodes or the proteins within the graph. Then we are defining the position that where this interaction will take place within the interaction network. This is the variable. Pos is basically a position. It is a variable storing the positions of these nodes. Here we are using the PLT that we have defined here. Matplotlib.pyplot. Here we are defining the figure size. This is the height. This is the width in inches. You can change your figure size according to your need. Here we are basically drawing the network nodes where this is the graph, this is the position of those nodes, and sizes of those nodes we want to place is equal to 500. You can change this node size according to your need, either 400, 300, or you can also increase it to 1000, 2000. Then we are defining an empty list edge score weights. Here weights are basically representing the scores between the edges. Then we are iterating over these edges where U represent protein 1, V represent protein 2, and D represents the information stored according to their edges. So here we are basically appending this information by getting this information from here, D, that contain information about its score. We are appending this information into this list, and then we are basically normalizing their values based on their minimum value and the maximum value. Here we are defining that whatever the minimum value within the edge weights, it will be equal to the minimum value in this color map, and whatever the maximum value in our edge weights will be equal to Vmax. It is defining the normalization range that normally consists of 0 to 1. Then we have CMap, color mapping. The color mapping that we are using here is cool-warm. This means that those genes that has less interactions will be represented by cool colors, and those having strong interactions are represented by warm colors. We will discuss it further when we will draw a interaction network. Next is to draw edges with varying weights and colors based on the score. So whatever the score of two proteins, we will define their edges with different colors. As we have already discussed that those proteins having less interactions will be represented by cool colors, and those having strong interactions will be represented by warm colors. So here we are basically using the same loop that we have used above. U represent protein 1, protein 2, and this is the information associated with the edges. And then we are basically finding the edge width that will be based on the minimum value of edge widths divided by maximum edge widths minus minimum edge widths. Then draw Networkx edges on the basis of this information, that is this graph, positions, edge list. This is protein 1, protein 2, based on their width and their edges colors. Then draw labels on them. These labels are basically the names of the genes within the nodes. Their font size is equal to 10. The figure that we will basically generate, its name will be gene interaction network. Along with this, we are also generating a color bar that will show the range of the interaction scores. Here we are using normalization is equal to normalization, color mapping is equal to color mapping, and the label we use for that color bar is the interaction score. And then plt.show is basically used to show the network. Now at last we have the step 4 where we are running our code. We have a variable genes that contain a list of genes for which we want to find the interactions. This API key, and then we are defining a variable known as data that is equal to fetch underscore interactions function that we have defined above, that contain genes and API underscore key. If this data is not equal to none, then we will print this message. And then we'll call this function visualize underscore network that contains this data as an input parameter. Else, if data is equal to none, then we will print this error message. This is the output that we will receive from this code. This is the gene interaction network. Here the dark colors shows the strong interaction, and as the tone of the color decreases, the quality of the interactions also decreases. This is a color bar that represents lower interaction to higher interactions. These genes represent that it has interactions with only 3 other genes, and also this interactions is very weak because it is near to blue color or a gray color as represented by our color bar. So in this way, you can find out your gene interaction network using this code. I will provide the link of this code in the description. Make sure to check it out, and if you have any queries, do let me know. That's all for this lecture. See you in the next video.